In this video, we're going to look at examples of algebraic proofs. An algebraic proof is an argument made to prove the answer to an algebraic equation. I'd encourage you to take a minute and pause the video and read through these two paragraphs to make sure you understand a few of the basic guidelines about proofs. You'll notice the key points are that you have to go step by step, and you have to make sure you give a reason for each of your steps. Go ahead and hit pause on your video, read through this, and then look through these three examples they give you. Okay, so I'm hoping that you've read through that. If we look through these examples, a couple of things they'll highlight. Notice in this equation they gave us something to start with and they asked us something to prove. So they gave us the statement x divided by 5 minus 2 plus 4 equals 7 and asked us to prove that x must equal 25. And then they gave us step-by-step examples, going through one step at a time and giving a reason for each of their steps. Notice they didn't show their work, so on this side they substituted in the fact that negative 2 plus 4 equals positive 2, but they didn't show any work there. Or maybe an easier example is the next step. They subtracted 2 from both sides to get x over 5 equals 5, but they didn't show that step of subtracting 2 to both sides. Those aren't necessary in a proof. It is necessary that we give a reason for each step along the way. Notice a couple of the notes they made over here. This is not addition or subtraction because like terms were combined, so negative 2 plus 4 are just like terms. That's the substitution property. Be careful if you're abbreviating. It's much better if you just write out the words, because if you just abbreviate, it can be hard to tell the difference between substitution and subtraction property. Also, notice that only the steps were shown. They didn't show all of their work. In the next example, again, here's some examples step by step. Pay attention to it. It says nothing was simplified yet. On the first step, all they did was use the distributive property. Again, the most important thing to remember with proofs, well, you have to have a reason for every step you do, but also you can only use one property at a time. So notice they had to use all of these different steps because they were doing these different properties. They were substituting, they were adding, subtracting, dividing, and then finally using the symmetric property. Alright, the last example, the note they make to the side says it's usually wise to show both subtraction steps, but the reason only needs to be written once. So they did this in 2 steps, but it was subtraction both times. You could write subtraction twice if you want, but since it's the same, they subtracted 2x from both sides and they subtracted 5 from both sides. They showed those 2 steps individually. Okay, so we're going to try a couple of examples on our own. So with proofs, if you read through those examples, you always start with what you're given. In this example, we're given 3x plus 8 equals 23. Sometimes with algebraic proofs, we're given what we're trying to prove, and other times we're just asked to solve for x, and so we don't know what the answer is going to be yet. We're going to have to figure that out. So in this example, if we were solving this equation, the first step we'd do is subtract 8 from both sides. So our reason there is going to be the subtraction property. And again, when we write this, we just have to show what would be left over after we've subtracted 8 from both sides. So if we subtract 8 here, we're left with 3x. If we subtract 8 from 23, we're left with 15. And our next step, we divide both sides by 3. So that's the division property. And if we divide both sides by 3, we end up with x equals 5. Since we're trying to prove what x equals, we have x equals 5. We're done there. Alright, on number 18, again, we're going to start with what we're given, so where we start with proofs. If I was solving this, the first thing I would do is add 3 to both sides, so that's going to be the addition property. If I add 3 to both sides, I would end up with x over 5 equals 13. And then to get rid of that 5 on the bottom, I'm going to multiply both sides by 5, so that would be the multiplication property. I would end up with x equals 13 times 5 is 65. So these two examples were pretty simple. They were just three-step proofs. Start out with what we're given and then solve the equations. Let's look at two examples. I'd encourage you to try these two on your own and then hit play and I'll walk you through them. But you might pause it and try it on your own first. So if you've tried this, we're going to start by writing our given. First thing I would do to solve this is the distributive property. I'm going to distribute that 8. So 8 times 6 is 48. 8 times x would be 8x. On this side I have x minus 1. The next step, I would start combining like terms. So if I use the subtraction property and subtract x from both sides, if I subtract x from both sides, I'd be left with negative 1 equals 48 plus 7x. And then I can subtract 48 from both sides and get negative 49 equals 7x. And again, that's the subtraction property. We can write it again, or we don't have to since it's the same thing. I don't make those little marks saying the same thing as above, but we don't have to since it's the same step. The next thing I'm going to do is divide both sides by divide by 7 to find out what x equals. So we have negative 7 equals x. And lastly, if we rewrite this as x equals negative 7, that would be the symmetric property. Alright, our last example. 5x minus 3x plus 1 equals 1 is what we're given. I'm going to start by substituting in the fact I know 5x minus 3x is 2x. Then if I subtract 1 from both sides, I'd have 2x equals 0. That's a subtraction property. And if I divide both sides by 2, I'd get x equals 0. Since I divided, that'd be the division property. And I should have mentioned this before, but you know from Algebra 1, every time you solve an algebraic equation, you can check your work by plugging back in to see if it works. So 5 times 0 minus 3 times 0 plus 1 equals 1. That is correct, it works. We check over here, negative 7 minus 1 would be negative 8. 6 plus negative 7 would be negative 1 times 8 would also be negative 8, so it works here as well. Alright, there's some examples of algebraic proofs.